Hello, welcome to the New Stack Makers podcast. This week we're recording on the show floor of the Cloud Foundry Summit. Catching up on the latest news about the Cloud Foundry platform and what's happening. We have to thank our sponsors, Cloud Foundry, for allowing us to be here and getting the latest news. And today we're with Cloud Foundry CTO, Chip Childers, who's going to talk us through some of the announcements at today's show. Hello.
Absolutely. Always happy to be on the podcast with you.
All right. Fantastic. There was a lot of interesting tech details that were announced today, and I want to kind of delve into them. But first, maybe we could talk a bit about the theme for this year's show and how it applies to some of the announcements that are taking place. What's going on with Cloud Foundry? How are you guys expanding and accommodating a evolving user base?
Yeah, so the theme of the show is building the future. And that really applies in two ways. It applies, of course, to, and I think we'll spend a lot of time talking about this, but it applies to the contributors that build the Cloud Foundry platform. But it also equally applies to the end users, right? Because the whole reason why companies like American Airlines or Charles Schwab or Comcast or Dick's Sporting Goods, or any of these names that we know are really focused on cloud-native platforms is that they're really trying to use software as a competitive advantage in the market that's extremely technology-centric now. Every market's become technology-centric. So they're building the futures of their companies, using these technologies, these open source platforms that they can build off of, right? So dual meaning.
Nice. We had a great Pancake podcast this morning where we had Rick from Comcast online, and he was talking about how they had a breakout of their individual business groups so they could collaborate together on offering unified services across channels. So I'm hearing collaboration is a big theme here.
Yeah, collaboration is a big theme. Last year I spent time talking about the notion of building bridges between communities, and I did a little bit of a callback to that because it's this idea that we're building bridges is all about how do you collaborate more. Mm-hmm. Right? That happens in the open source communities. They need to build bridges between each other. That collaboration is, what we heard from Eric at American Airlines. That's what the customers and the end users want. Is they want everything to work well together. But building bridges also inside organizations is really important, right? So we released our latest round of research. And one of the key findings in that was that truly we've seen a material and significant drop in either people and technology being the reason why transforming is hard, the reason why companies are struggling to use software effectively as a strategic thing. The number one challenge, and this is by orders of magnitude almost, it's culture. Right. So if you think about building bridges, the open source community has a lot to share with companies about how they deal with internal silos. Right. Rethink the way that they operate as an organization, become a learning organization. The flip side is there's a lot of success in large enterprise. They're demonstrating how to do that in highly siloed, previously highly siloed environments, and I think the open source community can actually learn from that in the same way, right? Because projects are sort of like, you have Kubernetes, you have Google's Istio project, we have the Cloud Foundry application runtime. These are you can think of them as isolated communities, but that's actually not the right way to think about them. It's actually all one giant open source community. Many contributors contribute to many of these projects. And we need to think about how we break down the silos across projects, just like organizations that have effectively begun their transformation cycles have broken down those silos.
Nice. Well, let's dig into some of these bridges. Let's take a look at some of these bridges. The first one that really surprised me, I have no knowledge about, build packs at all, but you guys are evolving the build pack, and this is actually a collaboration with Heroku. Where did that come from? What's up with this?
So if you back up in the history of the Cloud Foundry platform, it was essentially a Heroku clone, right? It was an open version of Heroku.
So what do build packs do?
What build packs are responsible for is they represent the logic to go from code that you're writing and actually get it turned into a container, right? So they're able to detect whether they have responsibility for it. Let's say Ruby, they're the Ruby build pack in the platform. So they notice that code that's been shipped in, it's Ruby. They then are responsible for kind of doing any of the compiling, drawing down dependencies, and packaging this thing up so then a platform can run it.
Right.
Now, that's the result of that is a container.
All right,
But what's important to understand about build packs is that, and this also applies to this next generation build pack project. Build packs have both developer as well as operational value, right?
All right.
So the value for a developer is that it makes it just push the code. You don't build a Docker file. You don't have to go to a container build service. The platform itself will take that responsibility for you.
Right.
The second, from a operator standpoint, is that when you think about the code or the applications running in a platform as being a combination of the source code, you can actually have the platform recreate the containers. So where does that become valuable? Well, it becomes valuable, for example, if you need to patch the underlying root file system because there's yet another OpenSSL vulnerability, right? The story in our ecosystem, a few years back with Heartbleed was that our community had a new root file system available. It propagated through all the distributions, all the commercial distributions, all the open source users. Companies were patched for Heartbleed very rapidly because it could just roll through the clusters. And so there's a supply chain thing that's going on with vulnerability fixes through the open source projects. Build packs make it really easy for operators to not have to go back to the development teams and say, you need to repatch, right? Run your pipeline again. Think about that from a scalability perspective, right?
Yeah.
You have a small platform operations team supporting thousands of developers, thousands of applications that the developers wrote, and in many cases, because of the way build packs work, some of these core libraries that every app relies on, you don't have to go back to any of those developers when you need to patch it.
Okay. All right.
So it's a platform operations team. Point of leverage for a platform operations team that allows the Cloud Foundry community of end users. They regularly see ratios of let's say one operator to thousands of developers that they're supporting, and scale that up. You get a team of 10 developers. You've got tens of thousands of 10 operators. You have tens of thousands of developers you could support, and that's a very, very regular occurrence, right?
Wow.
So with this the Cloud Native Build Packs project is a project that specifically Pivotal, who of course is a key part of the Cloud Foundry community, and Heroku, one of the originator of the build pack concept, they got together and said, these two build pack ecosystems have forked a bit, right? They've separated a bit. But we've both learned a lot through the journey of, evolving over the last many years. And it was time to come back together. And at the same time, take advantage of the industry standardization around the Open Container Initiative image specification, right? So take advantage of layers, take advantage of some of the functional capabilities that Heroku has added, some of the functional capabilities that the Cloud Foundry community has added, and basically unfork these two communities. So that's a CNCF project. It exists in the Cloud Native Computing Foundation as a sandbox project, but it's essential now to the future of Heroku, and it's essential to the future of the Cloud Foundry application runtime.
Nice. And you were talking about some of the benefits that would accrue to operators and developers. One is, I think, multi-build pack capability. How does that work?
So historically, what would happen? Remember, you got to think about build packs as the logic that will compile your code. It will basically go from I have code in a Git repository into, or just locally, into a running container. And so what was occurring was that companies were having to fork, let's say, the build pack for Java. They would fork that internally and have their own version of it to inject things like application performance management, right? That agent. It might inject a step to do static code analysis for security vulnerabilities.
Nice.
That forking was very inefficient. So what multi-build packs does is it allows you to string together a series of build packs that can take different responsibilities for different aspects of what you want to occur, so that you can, for example, again, operator efficiency here. By policy, I might want all code that's going to be pushed to go through a static analysis.
Okay.
So then as an operator, I could set a policy in the platform to say, every time code is pushed, after the initial developer-centric build pack does its thing, run the static analysis, or before the standard language build pack does its thing, run this analysis. So it allows each deployment to have policy-centric steps into the build pack pipeline. The second thing, though, is that a developer themselves, if they have a unique need, they don't have to fork the thing itself. They can choose to build their own, let's call mini build pack for just a small discrete thing they want to do that's different. And they're not forking the whole Java build pack or Ruby build pack or Python build pack. So it's a composition tool.
Nice. It sounds like it could potentially streamline a lot of CI/CD pipelines in terms of...
It's not quite the same as a CI/CD pipeline. And although I guess in some ways it sort of sounded very analogous to it. But what we've seen is that there are different times when you want the CI style of thinking about pipelines, right? Super important to development, super important that they run tests. But often the target of a CI pipeline is that you want running code somewhere, right? More continuous delivery of that code. You get through all the CI pipelines. The way that multi-build packs can actually work is they can be effective for a developer who's just trying to iterate very quickly without checking the code in, right? So they can do things that way, number one. Number two, it can also operate as kind of a last checkpoint that the platform that will run the software, not the CI system, which a developer might be able to modify, but the platform itself can force certain things to occur to the code as it comes in.
Nice. So it's more of an operations tool than a...
Well, it's both, right? Because when you're developing without doing commits, you can still push code into Cloud Foundry, into Heroku. That might be part of your development cycle, right? And you just want to add some functionality as you go. So it's these are building blocks. Different enterprises, different end users are going to use them in different ways. The composability is important at every step along the software lifecycle. So this is just another piece of the whole software lifecycle that has now more composability.
Nice. All right, fantastic. Now, another project that I just heard about new at this show was, I thought I how to pronounce the name correctly, but Project Irini?
Irini. Yes.
Right.
Yes.
And this was first proposed by IBM. And tell me what does this do, basically?
Yeah, so it's actually very straightforward. The Cloud Foundry application runtime, at the time it was created, initially open sourced back in 2011, it was a container-centric platform, right? This is before Docker existed. This is before Kubernetes was existed and was open sourced, and so we have a long lineage of using container technologies and actually having to build them. Now, what's occurred historically over the last several years is that the broader open source community has done a great job of creating general purpose container tools, whereas what we've built as a community, it's been very focused. They've been purpose built for our use cases, and so starting a couple years ago, we've been embracing the components that are coming out of, for example, that came out of Docker with the Open Container Initiative's Run C, right? We were the first platform outside of the Docker software that had large-scale production use of Run C across our user base. The same thing occurred when, as we moved to start to adopt Container D, right? Slightly higher level of abstraction. So Project Irini is saying, look, we also have a even higher level abstraction. We have this thing called the Diego scheduler. It's a container scheduler.
Yeah.
Purpose-built for the Cloud Foundry use cases. Solves a number of different use cases. It was built to have first-class support for the Microsoft Windows platform, right? So it's basically blazed a trail because we're able to be laser focused on the PaaS use case.
Right.
The underlying scheduler that we've built, and that was the second generation of a container scheduler. It's laser focused, but now that the general purpose tooling has reached points of maturity, we want to embrace them. And so the Arini project was about saying Kubernetes has reached the point where we as an ecosystem think that we can now trust it, and we want to begin the process of adding it so that it's an option in the architecture.
Okay, nice.
So similarly, a couple years ago, we made a transition from our old architecture that was referred to as the DEA style architecture over to the Diego layer.
Right.
We did that with a lot of maturity. A lot of open source projects will just kind of turn on a dime, go a different direction. Right. What we did was we had our whole community working to get Diego to feature parity. And then there was a whole phase where we worked on performance and scale parity.
All right.
Once it achieved performance and scale parity, we then gave the consumers, right, the downstream distributions, the users of the open source, another 6 months of runway where security updates were still happening to the old architecture.
Right.
Now, because of that, we have experience in evolving this architecture over time, and Arini just represents what is potentially the next step in our architectural evolution, right? It allows us to take Kubernetes and use it in place of Diego.
Right.
For those use cases that Kubernetes is now mature enough to handle. Right. But it's going to be a transitional process because we're not going to strand any distribution. We're not going to strand any open source user. We're going to do this purposefully, carefully, and thoughtfully. At the same time, a lot of I mentioned earlier about bridges. You brought up bridges. Right. Most of the companies that contribute engineering efforts to Cloud Foundry also contribute significant engineering efforts to Kubernetes, also contribute to Istio. Right. So it really is one big open source community, and many individuals are popping between the two. So as we, as a Cloud Foundry community, think about this evolution, what occurs is we also get more deeply involved in that general purpose, open source project. Istio is a great example of that with a lot of the performance work that's been going on there. You've seen pivotal engineers diving in. You've seen, IBM, of course, huge contributor there, one of the founders of the Istio project.
Istio being the service mesh.
Yeah, service mesh. I know, I pivoted, changed topics on you. But
it's used in conjunction with Kubernetes.
It frequently, yeah. It's one of a number of options that are available. It is the choice that the Cloud Foundry community has made, because that's the other big integration that we talked about on stage today, right?
Excellent. So it sounds like at some point in the near future, Kubernetes will have feature parity with Diego as from the perspective of Cloud Foundry users.
Yeah, that's a really important perspective, right? Because Kubernetes is general purpose and solves a number of things that the CF architecture doesn't need to or want to solve. So sometimes, previously folks have tried to almost paint an apples to apples comparison between Cloud Foundry and Kubernetes. And, that's number one. If you really understand Kubernetes, you understand that it's a platform, a container platform for building platforms, right? There's a lot more that you need to have to make it useful to a developer or an operator. And so, the kind of the process of bringing that in has really been one of building that bridge to the community and, of evolving and bringing our use cases to the forefront of that community, but while respecting that they have a much broader solution, right? It's a very general purpose tool, and we're coming with very specific use cases that we're looking to have solved.
Excellent. This makes perfect sense for the Cloud Foundry platform. You're not duplicating effort. What do you suspect that there will be additional capabilities that Kubernetes will offer your end users down the road?
Yeah, I think that comes in two ways, right? So for a while, the Cloud Foundry ecosystem has supported a version of Kubernetes, or a distribution of Kubernetes called the Cloud Foundry Container Runtime. Pivotal and VMware commercialized that now as the PKS product. So what I'd tell you is that we know without a doubt that different abstractions solve different problems for the end users. Container as a service makes a lot of sense for ISV package software. Those that have internal development workflows that produce Docker images, there's a number of use cases that raw access to Kubernetes really does make a lot of sense. Optimizing for custom development is what PaaS, or the Cloud Foundry application runtime, is really focused on. And then increasingly, although I think it's still very early, the notion of function as a service also has a use, right? It's
Sure.
It's being used heavily for event-driven processing or glue code, frankly, between in bigger systems.
Yeah.
Those tend to be the two top, right? So either like just pure event-driven processing, dealing with event streams, or it deals with how do I glue together some applications and respond to a database record showing up in here and push something to S3, right? So these different abstractions should work very well together, and that's what's actually really exciting, I think, about this next phase of the open source cloud native kind of community, the broad community. We're bringing these projects together.
Nice. I don't want to keep you here too much longer. I know it's your busy day, but there's a lot of interesting stuff about the work that you're doing with Istio and Envoy in terms of providing a service mesh for the Cloud Foundry platform. And again, I'm kind of curious, what is Istio and Envoy bringing to the table here?
Yeah, so this is another story of when we purpose build something, it solves a problem. When we then see that there's a more mature or that another project has reached a point of maturity that's a general purpose solution,
right.
that introduces the opportunity of ingesting it into our architecture. So I think there's a lot of possibilities now that Istio has been brought in as an option. Envoy, we were very early in adopting that. Envoy has been rolled out into a lot of the Cloud Foundry deployments out there already. Istio Pilot's a little bit different because it is achieving a particular scale in the way it's integrated. It's not quite scalable enough, but making a ton of progress. This is where, again, huge contributions in the Istio community from Google and IBM on scalability. But as it reaches the point where it scales up, that's going to allow more and more Cloud Foundry environments to have an Istio-based networking environment.
Nice.
So features that are starting to be enabled, because it's not just about, generally we talk about hiding things, right? Developers keep things simple, but when you have a general purpose tool that's part of the architecture, it allows us to be thoughtful about how do we enable some advanced capabilities in a very smart way for the developer.
Yes.
Because anybody who's looked at the YAML files that make up policy in Istio, that's not something you really want to hand a developer if you want them to be productive.
I did
right?
not know that.
It's supremely powerful, but is that really productive? So what we focus on when we think about these integrations is not just architecturally how does it get brought in, but what is the right developer experience interacting with that subsystem?
Right.
That gives you, for example, you saw weighted routing. Yui Kao yesterday on the main stage showed, early view into here's weighted routing. Weighted routing allowing a developer to say, let's actually weight more towards this version of the application versus another version of the application. Right. And how a developer does that is something we're still working towards. But
that's what the service mesh is for, is that fine-grained tunability.
Yeah, it is. But we want to make sure that the developers aren't cutting themselves by accident with a sharp knife. We want to make sure that it's a safe knife that isn't the full capability, because that's not effective. But the operator should have a lot more control, and that's where direct access into Istio makes sense.
Nice. All right, fantastic. Well, we're seeing a lot of bridges here at the Cloud Foundry Summit here this week. And Chip, I thank you so much for taking time to get us up to speed on these new announcements.
Absolutely. Happy to be here.
All right. Thank you.
Thanks.